So let me just find the semester test for you guys. I think it's probably going to be easier to do a share screen on this. Let me see where I can find it. So semester test. Okay, so stop sharing this. Yes, you will have more questions in the exam. So for the exam, I will tell you guys now. There is a total of 61 questions. From that 61 questions, 54 is multiple choice, and the last 7 Can everyone still hear me? I apologize about that. Load shedding started my side. So it's like I said, so there is going to be 61 questions in total. The first 54 questions is multiple choice, so 54 marks. And then the last 7 questions is a bit longer questions. And I might give you one more tip at the end of this. No problems. I hope your exam went well. So yes, I've seen a nebula via my telescope. I regularly observe the Orion Nebula. That's one of my favorite objects to observe. So I'm just quickly going to share my screen so we can go through the memo of the semester test. Let's see. This one. Can you guys see my screen? Awesome. So for the first question that we had is exact. So what is the average distance from Mars to the Sun? So that is, if you know, the average distance from Earth to the Sun is 1 AU. So Mars must be a little bit faster. So 0.9 AU is below Earth's orbit. So it's closer to the Sun. 0.72 AU is also closer to the Sun. 1 billion kilometers is way too far. 2.3 million kilometers is way too short. So 1.52 AUs is correct. So what is the magnification power of your telescope? So my telescope is a 11-inch Celestron HD. It all depends on what lenses you use with it as well, but I use for my own personal use, I have a 11-inch Celestron and I also have a 4-inch Celestron. Then question number 2. a star's 15 light years away, then the light we see left the star 15 years ago. Question number 3. Jupiter is on average 5.2 AU from the Sun. So what is the approximate orbital period? So are conversions such as AU light years given? No, because that's something it's so easy to do. So if you plug this into Kepler's law, so if you remember, I've provided this in the formula sheet. So if you literally just use formula number 1 over here, if you plug that in, then you will see the answer is 12 years. Then question 4. The two most abundant elements in the Sun are hydrogen and helium. Question 5. Absorption lines in a visible portion of the spectrum of a star that are produced by hydrogen are from the Balmer series. A parsec is 1.3 light years, so that's the definition that fits here in this question. So will we get conversions in the exam, or do we need to know them all? So it's, you don't need to do conversions. So it's easy to do. So light travels at 300,000 300 times 10 to the power 8 kilometers per second. So then you can figure out how many AUs that is and how many kilometers that is. Can you guys hear me? Okay, don't know what happened there. Then question number 7 that we've done. So sunspot is 4,500 Kelvin and the temperature is 5,880. So the answer is 2.6. Then in a binary system, the less massive star is the furthest from the center of mass. Question 9. The magnitude scale can be used to indicate the apparent brightness of a celestial object. Question 10. Apparent visual magnitudes are given. Which star would appear the brightest to an observer on Earth? Alpha CMA, that's minus 4.6. So yes, that's a definition you must know by heart. One astronomical unit is 150 million kilometers. The magnitude scale is logarithmic because it is based on response of the human eye. Question 12. Star A has an apparent visual magnitude of 15.4 and star B has an apparent visual magnitude of 12.4, and you can do this probably closed eyes already. You know this is 16 times fainter. Question 13. The point in the sky directly above an observer is called the zenith. Question 14. Southern hemisphere winters are colder than southern hemisphere summers because E and D. So the light from the sun shines more directly in the southern hemisphere during summer, and the period of sunlight is longer during the summer than the winter. Question 15. When we say that gravitation is universal, we mean that it is a property of all matter. Question 16. Gravity obeys the inverse square relation. The statement implies that a force due to gravity between masses will increase as the distance between the two masses increase, so the 1 over r squared law. The numbers below are given parallaxes values of stars. So the star closest to Earth will have the largest parallax. So number E. Question 18. On the HR diagram, white dwarfs are found in the lower left corner below the main sequence. Question 19. Convection is important in stars because it increases the temperature of the star. Question 20. Large optical telescopes are constructed to have segmented primary mirrors. 21. Astronomers build telescopes on tops of mountains because there is less air to dim the light. That is true. Seeing is better is true, and CCDs work better when there's less oxygen in the air. So it's all of the above. Question 22. An atom that is excited can emit a photon when the electron moves to a lower energy level. Question 23. The most common stars are lone main sequence stars. What is or are the hot gases that are moving extensions of the sun's corona? Solar wind. Number 25. To determine the radius of a distant star, we need to know its temperature and luminosity. Sunspots are known to be magnetic phenomena because the Zeeman effect is observed in sunspots. Number 27. To determine the radius of a distant star, we need to know its temperature and luminosity. Number 28. How does a gas cloud become hot enough? It's through compression by its own gravity. Number 29. Kepler's second law implies that a planet should move at its greatest speed when it's closest to the sun. Number 30. The nuclear reactions in a star's core remain under control as long as pressure depends on temperature. Number 31. The total mass of binary system can be calculated from the semi-major axis and a period of the orbit. Number 32. Sunspots are dark because sunspots are cooler than the surrounding surface. Question 33. Stars in a cluster are all have the same age, that is true. All have the same chemical composition, is true. All have the same luminosity, not necessarily. D, all of the above. So the only answer is E, A and B. They have the same age and the same chemical composition. 34. The options below list the spectral types of 5 stars. Which one has the lowest surface temperature? That is an M7. Which of the following stars, no, this question looks like cut off, so can't see what I've written there. So, which of the following stars is the most dense? So, a white dwarf. The proton-proton fusion reaction in the sun needs a high temperature to overcome the Coulomb barrier. Number 37. In a binary system, the less massive star is furthest from the central mass. Question 38. The sun is 1 AU from Earth. Number 39. Which of the following people accept the heliocentric model of the universe? Tycho Brahe. Number 40. The ecliptic is the path that the sun appears to follow on a celestial sphere as the Earth orbits the sun. Question 41. The Copernican system was not accurate in predicting the positions of the planets because it included uniform circular motion. Number 42. The long wavelength of radio waves is the reason why radio telescopes have poor resolving power. Radio telescopes must have large diameters. Radio telescopes must be above the atmosphere, or they're not electromagnetic radiation. So the correct answers here, A and B, is because radio telescopes has poor resolving power, and a poor resolving power is due to the size, 1, and the size of the radio waves. And therefore, radio telescopes must have large diameters. So that is why it's number E, which is answer A and B. In the Earth, in its orbit around the sun, moves about 1 degree per day. Number 44. Kepler's first law of planetary motion implies that the distance between a planet and the sun changes as the planet orbits the sun. Question number 45. The total mass of binary system can be calculated from the semi-major axis and period of the orbit. Question number 46. White dwarfs are, number A, cool with high luminosity, B, too small to be visible to the naked eye, C, the densest stars in the HR diagram, D is number B and C, or E, similar to brown dwarfs. So the answer is number D, and that is B and C, cool with high luminosity and too small to be visible with the naked eye. Then, the bit of the longer questions. So this, where did I save that now? So just going to open up, so this memo is not saved here. Just going to open it on my side. Where did I save this now? No, it's not this one. So where the hell did I save this? Just bear with me for a minute. Where did I save it now? Okay, looks like I can't find it now, but let's go through it this way. So, describe Galileo's four most significant telescopic discoveries. So the four most important discoveries is he discovered Venus had phases, the moon is littered with craters, there are moons orbiting Jupiter, and what we say is the last one. Can you guys still hear me? Looks like if load shedding my connection is bad, but what would you say is the last one? So the moon has craters, Venus has phases, there's other moons orbiting Jupiter. What else would you say is one of his other important discoveries? Yes, Mr. Sadat, you're correct, sunspots. Then question 48. What advantage does a large diameter telescope have over a smaller one? So we've done that in the mock exam. So that is greater light gathering power and greater resolution. On a radio telescope, greater collecting area and greater resolution. So what you know about astronomical units and light years, how we define a light minute? So how far light would travel in 1 minute? And how does a gas cloud become hot enough to ignite nuclear reactions? So the key word here, keywords I'm looking here for is a shock wave and compression because the shock waves compresses the gas cloud and that starts to then gravity sets in and then you get nuclear reactions. And then what is the predicted end of a white dwarf? And that is a black dwarf after a very long time. So you guys see that's not too difficult. Do you guys have any other questions? No, it's not going to be harder. It's going to be on the same level as the semester test. So yes, the exam weight, the semester weighting is 50%, exam weighting is 50%, and then you will have your final mark. So to pass the module, you need a sub minimum of 40% in the exam. So say, for example, if you have an 80% semester mark, in theory, that means you only need 20% for the exam to get an average of 50 between the two to pass. But unfortunately, that doesn't work. So even if you get 80% for your semester mark, you will still need to have a minimum of 40% in the exam to pass. So for example, if you have a 90% semester mark, you need 10% exam to pass, but you need a sub minimum of 40%. Anybody happy with that? Yes, I know. So I'm sure you guys will do well. Do you guys have any other questions? This is still a question and answer. So for tomorrow night's sessions, we are it's going to be question answers, so there's nothing really planned. So during that session tomorrow evening, I will be here to help you with any other questions. So no question, how are quasars formed again? Misremember them usually from due to being supermassive black holes that take a lot of mass. So a quasar is a form of active galactic nuclei. So active galactic nuclei as a classification of a quasar. So that is usually the center of a galaxy that contains more than one, well, supermassive black hole. Usually may have been two black holes merging, but its accretion disk around it is so bright that it outshines everything else. And that makes it a very active galactic nuclei, meaning very active center of the galaxy, and that is in short a quasar. So, Mr. Marvel, the scope is everything. Should I invest time into learning all the stages of terrestrial planets? We also have to know Kirchhoff's laws. So you don't have to know Kirchhoff's laws. Yes, you have to know Kirchhoff's laws. And Mr. Marvel, that's correct. So just because there are so few people in the class, let me unmute and give you another hint for the test for the exam.